I just made $500,000 in 5 seconds.
Now, Kenya has positioned itself as a regional champion for climate change, putting in place measures to pursue a low-carbon and climate-resilient development pathway. These include planting more trees and sustainable waste management systems. These measures have now encouraged more entrepreneurs to venture into climate-related initiatives. One such initiative is Octavia Carbon, a local venture specializing in direct air capture, or DAC, technology to remove carbon dioxide from the atmosphere.
Octavia Carbon is the Global South's first direct air capture company. We are designing and building machines that can capture carbon dioxide directly from the atmosphere, and we are the first to do this in Kenya and in Africa, and this is in effort to address the climate crisis. The name Octavia Carbon was inspired by a lady known as Octavia Butler. She was a fiction writer from the 90s, and interestingly about her work is she was among the first people to write about the effects of climate change in a book called Parable of the Sower. Inspired by that, we now as Octavians, we believe that we are taking that step to address the mess which is climate change, and by doing so we hope to position Kenya and Africa as a climate vanguard rather than just a mere victim of climate change. Kenya has the right ingredients to develop and deploy such a technology, and these key ingredients are the renewable energy, which is abundant in Kenya. We also have the right geology to store the carbon that we capture, and we have the right talent to develop it to whereby we have a globally competitive climate technology coming from Kenya. Our latest model is called Lenana, having a capture capacity of 10 tons of carbon dioxide in a year. Yeah. The goal is to scale all the way to the Batian peak, and for this we are hoping for a Batian that will have a capture capacity of 1,000 tons of carbon dioxide in a year. And this, we were motivated to name them after the peak because we know what's happening at Mount Kenya. Our snow is slowly melting out, the glaciers are slowly drying out, and as we are addressing this climate crisis, our goal is to restore it to its former glory.
Octavia Carbon is at the forefront of carbon removal technology by using direct air capture to combat climate change. Let's find out how that works.
Can generally describe our process in two sections. So we have the capture phase and we have the release phase. So what happens during the capture phase? This is the point where we actually pass air through our chemical filter. So the engineering is such that this filter will filter out the CO2 molecules in the air and allow every other aspect in the air to pass through. So we monitor the levels of CO2 in the filter to the point that it has actually absorbed to the maximum. It works like a sponge, right? When you put a sponge in water, it absorbs water up to a certain level, and then it can no longer absorb. So once we reach that level, we actually close down our machine and we move to what we call the release phase. So how do we release this CO2? Our chemical filter works in a way that if you heat it up, it actually releases the CO2 it had captured. It's like now squeezing the sponge. So we release this CO2 into our vessel, and then we extract it from that point. The whole technology is actually designed such that we utilize geothermal waste heat, not just geothermal heat. Basically, what this means is this is heat that has not been utilized in generation of electricity that's supposed to be released out. So we actually design our system such that we can actually utilize that. In comparison, you would require 1,000 trees to capture what this singular machine captures in a year. The footprint for the machine is at 2 by 2 meters. And the amount of land you'll actually require to plant 1,000 trees is insane, right?
Yeah.
So that means we can actually remove quite a lot of CO2 within a very small piece of land, which gives us leeway to utilize the land that we have in the country, because it is a limited resource, so we have to maximize it as much as we can.
It's incredible to see how science and technology are coming together to solve one of the most pressing environmental challenges we have today.
One of the perks of having direct air capture in Kenya is because 93% of our grid is renewable, with plans to get it to 100%, of course, and we can easily track where our electricity is coming from, assuring that the emissions are well considered. And we usually boast Kenya is the world's best place to build direct air capture, and this is increasingly being recognized on the global stage. A lot of players in the space are now wanting to come into Kenya. It's been more of a hands-on learning experience, whereby most of our team are young graduates, but they just know the challenge that lies ahead of us, and that motivates them, just knowing that they are coming to work to build a technology that's the first of its kind within the region, and this will give them the opportunity to address one of the biggest problems within our societies.
Yeah.
So yeah.
There's a gap in the cement industry. Today, 7% of global CO2 emissions come from cement production. Decarbonising this hard-to-abate industry is not possible with direct electrification alone. But with carbon capture, we can help future-proof operations, effectively reducing unavoidable emissions, relieving the CO2 tax obligation, and meeting new regulations and customer expectations. Let's close the gap on decarbonisation.
Climate change is the biggest problem of our era, and removing CO2 from the air at a massive scale is a crucial part of the solution. To tackle this challenge, Sirona Technologies is developing direct air capture technology, designed to extract CO2 directly from the atmosphere. Once captured, the CO2 is handed over to Sela, which specializes in CO2 mineralization, a process that locks the carbon on the ground for permanent storage. Kenya provides the ideal setting for this technology, with abundant renewable energy to power the machines and the right rock formations to store CO2 safely. It offers the perfect conditions for large-scale deployment. Last week marked a major milestone, the inauguration of Project Jacaranda, their first pilot plant. This achievement makes Sirona the fastest direct air capture company in the world to deploy a pilot plant on site, while Sela is now on track to become just the third company in the world to mineralize CO2 on the ground. The next step is to scale up. By adding more machines and expanding operations, Sirona and Sela aim to store millions of tons of CO2 per year, bringing a real solution to one of the biggest challenges of our time.